Alright guys, we're doing section 9.2 tonight over reflections. Let's do this. So a reflection is a transformation. We learned about transformations in section 9.1, right? We start with the preimage, usually something like ABC, do something to it, and then we get our final image, right? A prime, B prime, and C prime. So now we're going to talk about what this specific transformation entails. So essentially, what are we doing? We're taking this object. If you kind of just look at what we're doing here, for every reflection, we have a sort of line called the line of reflection. Okay, and this will be our guide for how to draw a reflection. But essentially, what we're doing is we're taking this object, our preimage ABC, and we're drawing it almost flipped over that line of reflection. Right? You can almost see if we grab this side and we flip it over here. This is what we end up with. Now, that's kind of easier to explain non-mathematically than to explain how we could get what this means mathematically. So here we'll go through these two properties that kind of explain that. So first thing first, if you have any point on the line of reflection, like point A is, then its image is actually that point itself, or A prime, right? So if you have a point here and we're trying to flip it across this line, but it's already on the line, well, it's just going to be the same thing. So if you have a point on the line, then the preimage is the same thing as the image, right? A is equal to A prime. Now, for the trickier part, any point not on the line M, right? So in this case, we'll talk about B or C. The way that we find where to draw our image from our preimage is first we will know that our image is on this is on a line that is perpendicular, that is a perpendicular bisector of M, right here, okay? So what it's saying is this line from B to its image, B prime, is the perpendicular bisector of M. So essentially what we're saying is to find out where to draw our image of B, first we need to draw a perpendicular bisector to our line of reflection. That would be what this is, making sure that it is in fact perpendicular. And then what we would do is just continue drawing along that line the same amount of distance that it took to get to the line. So we would continue along this line, boop, 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 the same amount of the same length of distance that it took to get to that line. So look at that. That's pretty neat. So that would be how we would mathematically find every single possible point. So if you did that for every single point on here, you would find it would be the same thing, right? Let's say we did it for some random point right here. Draw its perpendicular bisector to the line. Like that. That's pretty cool. And then we knew how to use the mouse, and then we just continued on that line past our line of reflection the same amount of distance, we would get its image right here. So this point goes through this reflection and ends up right there. So that's kind of the logistics of how you would do reflection. And now here's the notation for how you draw a reflection. So we have R, standing for reflection, of M, where M is the line of reflection, of ABC, boop, 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 then it equals A prime, B prime, and C prime. Nice. So very quickly we'll go over some properties of a reflection and what it entails. First things first, this is a rigid transformation, right? What does rigid mean? That means that the distances of both the images remain the same. So here we have side AB is always going to be congruent to side A prime, B prime. What else does that mean? That means angle B is always going to be congruent to also B prime. All right. And lastly, what we kind of noted up here, we have shown down there, is that the length to get from B to M is the same as the length to get from M to B prime, right? So then you would say that this line right here, B to M and M to B are congruent to each other. Okay, so then line B to B prime is twice as long as it takes to get from either one, B or B prime, to that line M, or line of reflection. Alright, now let's start looking at some practical problems that you could see that use this idea. So here we go. We got point P33, so we have a point P which is located at 3, 3, and we want to know what, using the notation we just learned, R, Y equals 1, P is equal to. Alright, let's flash back because I know you guys already forgot. So here we have R stands for reflection. And now down here we said that the subscript here, M, stands for the line of reflection. So here is M drawn, and here we're told the line of reflection is Y equals 1. So I'll just go ahead and draw Y equals 1. There we go. So see, now we have our point of reflection at where Y equals 1. I hope you guys understand why that's Y equals 1. And now we're going to reflect. Here we were reflecting A, B, and C across this line M. So now we'll be reflecting this point P across Y equals 1. So to find its reflection again, we start at the point we're trying to reflect, and we find the line perpendicular to our line of reflection. So here, pretty obviously, it would just be a line straight down, right? And we see here that it's 2 units away from this line of reflection. Oh, no. So what we would say is, well, it's along this line, and then 2 more units past that line. So ultimately, we would say that the answer to this question mark would be a point located at 3, -1. I hope that makes sense, right? Point of reflection goes across the point of reflection perpendicular to that line, and it's the same distance from our pre-image and our image to that line of reflection. So here is your first question. You might want to pause it, but actually just using this information you should be able to draw it out. If you have a point P located at 1, 2, I want you to solve for Z, right? Or just kind of do what we just did above. If we have a reflection at X equals 3 of P, what is that equal to? Alright, now to the fun part. So this will be what we're doing mostly in class tomorrow. And so what we're doing now, instead of reflecting just one point, is an entire object, or a triangle, right? So here we have points -3, 4, 0, 1, and 4, 2 drawn out on this graph, okay? And we want to draw and label what our y-axis triangle ABC would be. So as always, first I will set up our line of reflection, which is, let me make this yellow so you can see it, which happens to be just the y-axis. So now what you want to do is plot out our specific points. So as we did before, we will look at, we'll start with point A here. And we can see that to draw a line from point A that is perpendicular with line Y would just be to go right along this line right here, right along this x-axis. This y equals 4, right? Because you know that the x and the y-axis are perpendicular to each other. So you know if you just go along any straight x-axis, it will be perpendicular to this. So, and we also see that it's 1, 2, 3 units to get to a line of reflection, which means that if we just move 3 units, boom, 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 to the right, past this, we'll see that this is in fact a perfect reflection of A, and we get A prime. Now, here we have B. B is located on the line of reflection, so as we know, that will That means that B is equal to B prime. So B prime is already drawn for us right there at 0, 1. Last we have C. To go perpendicular to this line of reflection, we move 1, 2, 3, 4 units over to the left. So we'll continue moving. What is gone? We'll continue moving 4 units past that to 1, 2, 3, 4 right there. And now we have our 4 points. I'll label that really quick. We have our 4 points of A prime, B prime, and C prime. And we will connect those really quick to show you, that is way too thick, show you what it kind of looks like to draw a reflection of a triangle, right? So this looks kind of funky, but you can still see that there's some sort of reflective property here, right? If we had wanted to reflect this whole thing, let me see if I can do something like that. All right, so if we want to take this reflection across the y-axis, let's say instead of y-axis we said x equals 4. So if we just simply moved this line over here, x equals 4, it would still be the same image, right? We know we're not changing its size or angles or anything like that. It would just be moved over here. Okay? Now let's say we wanted to, that's not going to work, but let's say we wanted to change the line of reflection to right here. Well, we would simply be able to just, oh, that's not right, draw that right there. So again, we're never changing the shape of the image, it's just where we're placing it. Okay? And if we wanted to make the line of reflection I'm not going to pick it up. Well, let's say the line of reflection now was right here at the x equals 0, the x-axis, then it'll just be right there, right, with 1 between each one. So for tomorrow, you'll be thrown a lot of different scenarios, right? You'll have to be reflected over here, or like we did it previously. But if you just keep on with the basics that we've learned, it should be pretty simple. So, your last question for today, or question 2, we have triangle ABC and triangle A prime, B prime, C prime. Now, I want you to solve for n. Now, little help here, remember this little subscript right here is just the line of reflection. So tell me what the line of reflection is for this reflection to be able to reflect triangle ABC into A prime, B prime, and C prime. You might want to pause it now.